Welcome to News About Geology. Have you ever just stared at a huge mountain range and thought, how in the world did that get here? Well, today we are diving into one of the biggest scientific revolutions ever, the incredible discovery that the very ground we're standing on, it's moving.
For most of human history, something like the Himalayas was just a total mystery. It was just there, a permanent, solid part of our world. But here's the thing, it wasn't always there. So the real question is, how did it happen?
To answer that question, we basically had to throw out everything we thought we knew about our planet. It required a complete overhaul of our understanding. And the story of how that happened is just fantastic. All right, so our story really kicks off in a world where geology wasn't exactly a science yet. It was more a collection of myths, legends, and these really tantalizing clues that a few very sharp people were just starting to piece together. Get this, even way back in ancient Greece, people were finding these amazing clues. I mean, imagine being Xenophanes. You're climbing a mountain and you find a fossil of a fish. The only possible conclusion, this mountaintop must have been at the bottom of the sea. And Aristotle realized that whatever forces shape the Earth, they move way too slowly for us to see in a single lifetime. But for centuries, the main explanation was that big, violent events, like a global flood, created everything we see. But then, pioneers like Nicholas Steno came along. And here's what's so cool about this guy. He was a brilliant scientist, but also a beatified Catholic bishop. He started asking the hard questions, applying scientific principles, and arguing that fossils were actually the remains of ancient life. He was, bit by bit, laying the foundation for modern geology. So all this set the stage for the 18th and 19th centuries, when things really heated up. Geology went from just quiet observation to a full-blown scientific battleground over how old our planet really was and how it was made. The first big showdown was basically water versus fire. The Neptunists, led by a guy named Abraham Werner, were convinced that all rocks, even granite, had settled out of a giant worldwide ocean. But then, James Hutton, who we now call the father of modern geology, looked at rocks made from lava and argued for Plutonism, a world shaped by incredible heat from inside the Earth over unimaginable stretches of time.
And this led to the ultimate geological cage match, catastrophism versus uniformitarianism. Was our world shaped by sudden, massive disasters? Or, as Charles Lyell argued, was it the result of the same slow, steady processes we can see happening right now, like erosion and sedimentation, just playing out over millions and millions of years? His big idea, and it's a huge one, is that the present is the key to the past.
And when you started looking for it, the evidence for this slow, gradual change was just everywhere. You see those massive white cliffs of Dover? They're made from the microscopic shells of trillions of tiny creatures. That doesn't happen overnight. Or think about a stalactite in a cave, formed drip by drip by drip. It all pointed to a planet shaped by the steady, relentless hand of time. So just when everyone was getting comfortable with this idea of a slow, ancient Earth, bam. In comes this German meteorologist with an idea that was so wild, so completely out there, that the scientific world basically rejected it outright for 50 years. His name was Alfred Wegener, and his theory was continental drift. His big idea? That all the continents we know today were once smooshed together in one giant supercontinent, which he called Pangaea. And then, somehow, they broke apart and drifted to where they are now. And he had a mountain of evidence. He was basically saying, come on guys, just look at a map. See how South America and Africa fit together like a puzzle? He pointed to identical fossils of land animals on continents now separated by thousands of miles of ocean. He showed how mountain ranges on opposite sides of the Atlantic were a perfect match. It was all there. But you know what? The scientific community pretty much laughed him out of the room. And why? Well, for all his proof that it did happen, he couldn't answer the biggest question of all. How? What force could possibly be strong enough to push entire continents across the globe? Nobody knew. So, without that how, Wegener's incredible theory was dead in the water. All the pieces of the puzzle were on the table, but the most important piece was missing. The history of geology is packed with these kinds of amazing twists and turns. If you're into this stuff, you should really check out the fantastic videos on PGO Ricardo Valls' YouTube channel. He dives deep into these kinds of stories. So where was the answer? Well, it was hiding in the one place nobody had really looked, the bottom of the deep ocean.
After World War II, we finally got the tech, sonar, to map the ocean floor. And what we found down there, it was mind-blowing. There was this gigantic underwater mountain range that wrapped around the entire planet like the seam on a baseball. And the ocean floor itself was surprisingly young. Plus, these super deep, mysterious trenches at the edges of the oceans. The seafloor was not boring and flat at all.
And all this led to a radical new idea: seafloor spreading. What if new ocean floor was being constantly created at those ridges, pushing the older stuff outwards? This was it. This was the missing engine. The continents weren't plowing through the ocean crust. They were just passengers on a giant conveyor belt of moving seafloor.
And then came the smoking gun, the absolute proof. See, Earth's magnetic field flips every now and then. As new lava erupts at the mid-ocean ridges and cools into rock, it locks in the magnetic direction of that time. The result is a perfect, symmetrical pattern of magnetic stripes on either side of the ridge, an undeniable tape recording of the seafloor spreading over millions of years.
And just like that, everything snapped into place. Wegener's puzzle of fitting continents and matching fossils, the weird mountains on the ocean floor, those magnetic stripes, it all made perfect sense under one single beautiful theory.
And that is the theory of plate tectonics. Simply put, it's the idea that the Earth's hard outer shell is broken up into these massive, rigid plates. And these plates are floating on a hotter, weaker layer of molten rock underneath, constantly in motion. The entire surface of our world is a mosaic of these moving pieces. And pretty much all the geological action, we're talking earthquakes, volcanoes, the whole shebang, it all happens at the edges where these plates meet. Where they pull apart, new crust is born. Where they slam into each other, boom, that's how you build mountains like the Himalayas. And where they grind past each other, you get massive earthquakes. So what this incredible revolution really showed us is that the map on your wall, it's just a freeze frame. It's a single moment in an epic movie that's been playing for billions of years and is still going. The continents are moving right now as we speak. And that leaves us with this final, truly mind-bending thought. Our planet is constantly remaking itself. So what will the next chapter of its story even look like? The story of geology is far from over. It's an epic tale still being written in stone all around us. To keep exploring that story, you should definitely go check out the fantastic work of PGO Ricardo Valls on YouTube. Thanks for watching News About Geology.